Example 4. If a snowball melts so that its volume decreases at a rate of 4 cubic centimeters per minute, find the rate at which the diameter decreases when the diameter is 18 centimeters. Now, what we're going to assume about a snowball that this is a perfect sphere, because that's what happens when we make a snowball, right? We crunch it up right, it says it's perfect sphere to it, right? So it gets perfect, like if you throw it through the air, there's actually no friction on it because it's so perfectly spherical that it's going to be a great snowball. All right. So we have our perfect sphere snowball here. You can if you want. Step 1 of the process is draw a picture, right? So I'm going to draw a picture of our object. We have a snowball. The volume's decreasing, right? That implies to me the radius is also decreasing, as would the diameter be decreasing. So I know this snowball is decreasing. I'm going to draw arrows to demonstrate the decreasing volume of the snowball. And notice I put the radius as r, even though I know the radius would be 9. It says the diameter is 18 centimeters, right? But the radius is actually 9 centimeters. Okay. The reason I want radius is because I have a formula involving volume of a sphere involving radius. All right. I can find out how quickly the radius decreases. If I double that, that's how quickly the diameter decreases, right? So I know that 2r is equal to d. So that means 2 times dr over dt is equal to 1 dd over dt. That's a true fact of r and d. So if I can find out what dr over dt is, I simply have to double it to get what dd over dt is. That's what I'm looking for. All right. But again, for the sake of this problem, it's much easier to work with a radius than a diameter because that's what my volume formula for a sphere is. And what I need is something that relates the dimensions in this problem. And they tell me the volume decreases at a rate of 4 cubic centimeters per minute. So what they're telling me there specifically is the change in volume with respect to time is negative 4 centimeters cubed per minute. Why is it negative?
Decreases.
It's decreasing. Okay. It's very important when you put rates down that you always consider sign. Should it be a positive rate or a negative rate depending on what's happening in the problem? Volume is getting smaller, so the volume rate of change should be a negative rate of change there. So volume is something that might be important to me. All right. The other thing that's important to me, again, specifically diameter, because that's what they're asking me about. Find the rate at which the diameter is decreasing. But for the sake of this problem, it's much easier to work with radius. So I want to find out r and dr over dt. How many rates am I given in the words? 1, right?
Yeah.
All right. So 1 rate given in the words, which means I'm allowed to have 2 variables. V is variable 1, r is variable 2. So those are the 2 variables I have. All right. What does r equal?
R would equal 9.
9. Very good. The diameter is 18, so r is 9 centimeters. dr over dt is what we're looking for, right?
Yep.
The unit of speed here, rate, which should be, this is cubic centimeters per minute because volume is in cubic centimeters. This is going to be centimeters per minute because radius is in centimeters. The rates don't always have the same types of units on them. The per unit of time should be the same, but the top number sometimes, the top unit sometimes is different. All right. And do we know what the volume is right now?
No.
And it's not given to us. Maybe we need to know it, maybe we don't. We'll see. If we need to know it, we'll go back and find it. If we don't, it'll be fine. So, what is the volume formula for a sphere? One of our formulas that we memorized back in Algebra 1 when we mastered Algebra 1 and we were told to memorize all our formulas. That
That
was
was a long time ago.
yeah. Starts with 4/3.
4/3 pi r cubed.
Pi r cubed, very good. I was going to say there's probably a pi in it because it's circular. Circles usually have pi's in them. All right, 4/3 pi r cubed is the volume formula. Notice the variables we have, volume and radius, v and r. This is an equation that's true based on a sphere that relates the 2 units, or 2 variables, v and r. So that's what we're looking for in a good relating equation. Very often if you have a geometric shape involved, the formula for that geometric shape is going to be your relating equation. Occasionally you have to do some modification of that formula because you don't have enough variables. All right, so I've only got 2 variables. The formula only has 2 variables. That's great. We're in good shape. So at this point, if I differentiate, so I've got all this stuff here. Again, I don't know V yet, but maybe we don't need to know V. I got my relating equation. I'm ready to go. All right. So once you get that relating equation, once you are ready with that related equation, differentiate with respect to t. The derivative of v is 1, and then we're differentiating with respect to t. V is not t, so dv over dt is necessary. And then 4/3 pi r cubed is just one big structure. And let me just say something real quick, because I noticed some of you trying to do this. 4/3 is being multiplied by pi, which is being multiplied by r cubed. That's a product of things, right? And if you see a product of things, we start thinking, oh, the product rule has to be used here because it's a product of things. 4/3 is a number, pi is a number, r is a letter. If you have a letter times a letter, that's a product of letters, product rule is necessary. If you have numbers times letter, no product rule necessary. This is just a basic power function. If I have 3x squared, it's derivative of 6x, right? It's not 1d2 plus 2d1. That's the same picture. It's a little uglier, but it's the same thing. This is just a number. So just like I did 2 times 3 to make 6, I'm going to do 3 times 4/3 pi to get 4 pi, then r to the second power. And of course r is not t, so dr over dt. Okay. Notice that v is not in there. The derivative of v was 1, right? So v went away, so I don't even need to know what v is. That's fine. That happens sometimes. That happens quite often, actually. So again, if you get to a point where you know all but one thing up here, and you have a relating equation, go ahead and differentiate and see what happens. If you still need it, I could very easily put a 9 right there to figure out what v was, right? But I don't need to know it, so I don't have to do it. So at this point, what I'm looking for is dr over dt. This is where it is. R is equal to 9. dv over dt is equal to -4, so I'm ready to go. So -4 equals 4 pi times r squared. 9 squared is 81. Times dr over dt. So if I divide both sides by 4 pi times 81, I end up with dr over dt in exact value form. The 4's cancel, right? I get -1 over 81 pi centimeters per minute. And again, I wasn't asked to find the change in radius, I was asked to find the change in diameter. We've already established the change in diameter is exactly twice the change in radius. So if I double this fraction, we get that dd over dt is going to be -2 over 81 pi centimeters per minute. I would actually prefer an exact answer like that. If I was going for a decimal answer, just being careful about entry in our calculator. Bring it over here without making it go full screen. -2 is being divided by 81 in pi. So if I type in this, -2 divided by 81 pi, that's very typical that students will do that. The calculator thinks pi is on top there. It gives us this answer, which is wrong. If we wanted to type this in our calculator to get the answer approximately correctly, -2 divided by parentheses 81 pi and parentheses, that now 81 and pi are both in the denominator. That's the actual correct answer, -0.00785950034. So maybe 4.0079. Notice the rate of change of the diameter is negative because the diameter is shrinking.
We can
Okay.
leave it like that though?
Yeah, I prefer to have it like this,
Okay.
honestly. But again, if you are going to use your calculator, just be careful that if you type it in like this, pi is not on the bottom there. You've got to put parentheses around and keep it in the bottom. All right, your calculator doesn't know, well, anytime it sees multiplication, which 81 pi is an understood multiplication, anytime it sees a times show up, it's putting it in the numerator. So make sure that parentheses is there. But again, the change in diameter is negative, which it should be, right? It's shrinking. So that makes sense. The signs will work themselves out if you get all the correct signs in this box here. The signs will work themselves out like they should. All right. And sometimes one might be decreasing, another one might be increasing. It might not be noticeable, as far as what's happening specifically. So you might not know once you work it all the way out. Whatever signs on this answer, assuming you got all the signs right in your work, will be the correct sign for what's happening.